Okay, welcome back. Here we go. So there's another thing that needs to be discussed here, and that is a situation where the robot is off. It's sleeping quietly. It's not doing anything. There's no electrical power anywhere. And it gets the message to get itself going. And so it flips its switch. It turns on its energy source and begins to create electrical energy, and it starts waking up all of its central processing. And then central processing begins the process of waking up these hydraulic cylinders with respect to their ability to generate data transmission between the hydraulic cylinder and the central processing unit. So the central processing unit will send voltage to this coil, and that coil will send voltage to that coil, and that coil will take the voltage that it's creating, because it's on that rod, and it will send that voltage to the bridge wave rectifier, and that bridge wave rectifier will bring the voltage up into a decent form of DC voltage, and that voltage will be conditioned if it needs to be, and it will finally be sent over to the quark, and the quark will wake itself up and say, whoa, the robot has been turned on. And the quark will say, okay, and send a message to this 60 gigahertz transceiver and say to it, hey, piston transceiver, wake up, we're on. And really, as you can see, but I think in the real robot, there's actually 1, 2, 3, 4, 5, 6, 7. There's 8 in this drawing. I don't know that there's enough power to send 8, but there may be 4. So this quark, in a sequential fashion, will wake up these 60 gigahertz transceivers and tell them, get yourself going. And basically, electrical energy will go from the quark. The quark will control electrical energy, send it to the transceiver. The receiver will wake up and send data to the quark. The quark will send data to the transceiver. The transceiver will send data to the quark until this thing is, everybody's happy and it's functioning. At this point, the 60 gigahertz transceiver is in the 60 gigahertz transceiver that is in the piston is a fully functional data transmission reception device. It is available to send and receive data because that is one of its original capabilities. So it's sitting here awake, ready to go, and capable of functioning as a data transmission reception device. That exact same wake-up sequence would have also been sent to this yellow colored box that is the local area control processing system for the linear array of transceivers outside of the cylinder wall. And so this block of space will also have in it a quark and some RAM and EEPROM and whatever it needs to receive electrical power, realize that the robot has been waked up, realize that it needs to wake itself up, and then it will turn and wake up all of its little processors, and then it will run through its wake-up sequence and be sure everybody's happy and ready. Then it will begin to send out a little, hello, is there anybody there type of data event where this device is acting in its original capability as a 60 gigahertz data transmission reception device. Hello, anybody there? Hello, anybody there? Hello, anybody there? And at one point, there's going to be one of these in this array on the wall of the cylinder that is going to send a radio frequency data transmission signal down through the piston wall to a 60 gigahertz transceiver that is awake and functioning inside the piston wall, inside the piston, and that one will say, yes, yes, I'm here, I'm awake. And at this point, this system can be capable of sending status information of how it is available and ready to function to the central processing unit. And all of this activity is data processing. It has nothing to do with the sensing of position. It has to do with everybody waking up and getting ready. And when everybody is waked up and ready and they've done their little tests and they're in a position where they think they can do their work, they send a note to the robot central processing unit in the head and say, this particular hydraulic cylinder is ready to give you information. And the central processing unit will then send data requests down. And these data requests will go to this yellow colored block, which will then send these as data requests through the block, through the 60 gigahertz transceiver in the piston head, and to this quark. And so at this point, the 60 gigahertz transceiver inside the piston head is serving only as a data relay channel so that the central processing unit of the robot is able to communicate with the 60 gigahertz transceivers of the piston. And when all of that interaction and link up is proper, then finally the central processing unit of the robot can send data signals to this quark to say, I, the central processing unit of the robot, am now ready to ask about and receive position information about the position of this piston inside of this cylinder. So the not only the array of 60 gigahertz transceivers in the cylinder wall and all the parts on the cylinder wall, but also the array of 60 gigahertz transceivers inside the piston and all of the processing items inside the piston head. All of these can act for the purpose of moving data back and forth and do communications. And they have actually the ability to have two jobs. One job is communicating with the central processing unit of the robot. The other job they have is communicating data for the purpose of establishing the position of the piston head.